Hello friends, my name is Tushar and today we are going to talk about how to find minimum spanning tree using Kruskal's algorithm. So what is a spanning tree? A spanning tree of an undirected graph is a subgraph such that all the vertices are connected to each other, and then there is n-1 edges in the subgraph where n is the total number of vertices. So basically the subgraph represents a tree. What is a minimum spanning tree of a weighted undirected graph? A minimum spanning tree is a spanning tree such that the sum of the weight of the edges is minimum. So if you look at this example here, the minimum spanning tree for this graph will consist of three edges, AB, BC and DC. So we have four vertices, we have three edges, and all the four vertices are connected to each other to form a tree. So for this video, I'll assume that you know what disjoint sets is because it's a prerequisite to understand this algorithm. I have another video discussing disjoint sets using path compression, and if you have not already watched that video, please watch that video before watching this video. So in the next section, let's try to find minimum spanning tree for this example here. The idea of this algorithm is very simple. First thing we do is we sort the edges in non-decreasing order. Then, using this make set operation of disjoint sets, we create as many disjoint sets as the total number of vertices. Then we pick one edge at a time in the non-decreasing order and check both the ends of this edge and see if they are in the same disjoint set or different. If they are in the same disjoint set, we ignore this edge, and if they are in different disjoint sets, we merge those disjoint sets into one and put this edge into the final result. So let's try with this example here. So I have already created 6 different disjoint sets, and I have already sorted the edges in non-decreasing order. So first let's pick this edge AD. So A and D are in 2 different disjoint sets. So we'll pick AD into the final result, and using this union operation of disjoint set, we'll merge A and D. So this will become A and D in one set. Then we are going to pick the next edge BC. So first we are going to check B and C again are in 2 different disjoint sets. So B and C is also going to be in the final result. And we are going to merge B and C using this union operation of disjoint set. Then we are going to pick edge CD. So let's say this disjoint set is represented by A and this disjoint set is represented by B. So we'll do a find set and find C, and C belongs to set B, and we do a find set and find D, and D belongs to set A. So basically they are in 2 different disjoint sets. So we'll again pick CD for the final result and do the union of these 2 sets. So we'll have one set here, A, B, C, D. And let's say this set is represented by A. So then we are going to pick EF. So E and F are in 2 different disjoint sets. So EF is also in the final result. And we are going to do a union of E and F. Then we are going to pick the next edge BD. So B is represented by A and D is represented by A, which tells us that B and D are in the same disjoint set right now. So we'll just ignore this edge. Then we'll pick the next edge AB. A is represented by A and B is also represented by A, which tells us that A and B are in the same disjoint set. So again we'll ignore this edge here AB. Then we'll pick the next edge CF. So C is in the set A and F is in the set E, and so they are in 2 different sets. So we'll again pick this edge CF and merge these 2 disjoint sets. and then we pick CE, and C is represented by A, and E is represented by A, which tells us that C and E are in this same set, so we'll again ignore this edge. And lastly, DE. D is represented by A and E is represented by A, basically telling us that they are also in the same disjoint set. So we'll again ignore DE. So these are the edges which form the minimum spanning tree for this graph here: AD, BC, CD, EF, and CF here. So this 5 edges form together minimum spanning tree. So what is a space complexity? Space complexity is, in the worst case, whatever disjoint sets takes and whatever this result, whatever we store in the result. So it will be O of E plus V. What is a time complexity for this algorithm? So it will take, so if we have E edges, it will take O of E log E time to sort these edges in non-decreasing order. And then if you have watched my video on disjoint sets, so you would know that if there are n operations in this disjoint set, it takes O of n time. So rest of this operation would, in worst case, take O of E time. So E log E plus E. So in the next section, let's look at the code for this algorithm.
Code like algorithm is very simple. So the name of the function is get a minimum spanning tree, and it passes as a graph. First thing we do is we get all the edges of this graph, and then we sort the edges in non-decreasing order. And then we initialize a class of disjoint set. And what we do is we create as many disjoint sets as the total number of vertices using this make set operation of disjoint set. And then we are going to do is iterate through each of the edges in non-decreasing order, and for every edge get the 2 vertices of this edge and see if they are in same disjoint set or different disjoint set. So we get the root, we get the name of the set for all for these two vertices of an edge using find set operation, and check if they are in the same set. If they are in the same set, it means we are going to ignore this edge, and if they are in the different set, then we are going to add this edge into the final result and also do the union of these 2 sets into one. And then we move on to the next edge, and we keep doing this until we have edges to iterate through, and then finally return all the edges in the result edge. So as I said again, the runtime complexity is O of E log E to sort this the edges, and then O of E to do these operations, and the space complexity is O of E plus V. Thanks again for watching this video. Please like this video, share this video, comment on this video, check out my Facebook page at facebook.com Tushar Roy 25, and check out my GitHub link github.com mission piece interview wiki. Thanks again for watching this video.